Okay, so we've managed to successfully get expressions for our mass and stiffness terms, which leaves only our numerical flux from our weak form. So recall that we're evaluating this at the element boundaries as a result of the integration by parts. And because we have a constant linear velocity, our velocity here is just stuck on the outside times our solution. And this is the solution due to our numerical flux. So because we're using an upwind flux and we're assuming C is positive, this is going to be on the upwind element. So if this is element K, this is element K plus 1, this is element K minus 1, and we're looking at just element K here, then the flux on the right side is going to be due to the value of the boundary solution from the K element. So that's what's here with the K subscript on the right side of the domain. And then on the left side of the domain, again, because it's an upwind flux, we're looking at the value of from the left element here, K minus 1. And you have to be careful, this is the right side of K minus 1. Even though it's the left side of element K, it's the right side of element K minus 1. So that's why we're evaluating there. This is with respect to K minus 1. Now our weighting basis here, we don't have to worry about any sort of discontinuities or anything like that at the element boundaries. We're just simply looking at particular element bases here. So we're evaluating each of our weighting bases at the right side and at the left side. So notice that because of our definition of our weighting bases as ramp functions, they are 0 on one side. So if this is our weighting basis 0 and our weighting basis 1, clearly weighting basis 0 is 0 on the right side of the element, and weighting basis 1 is 0 on the left side of the element. So again, this is for each of our weighting bases. So if we were to examine this, let's say in the case where J is 0, well, we can see that our left term, or our left value, is clearly 1, right? So we can just simply substitute that in there. This is 1, but our right term is 0. So because this is 0, this whole term goes to 0. So we're only left with, for our first weighting basis, the following expression. And we'll just leave off the implicit one here. So what we're doing here is we're calculating, I suppose if I was planning better I'd put it over here, but we're calculating this vector. Okay, so this is for j equals 0. Now what about for j equals 1? Well, we can imagine, take a look at, so clearly the left-hand side is going to be 0. So in other words, this term goes to 0. But we have the right-hand side is equal to 1. So again, we'll leave off the implicit one, but for the second basis function, we have the following expression on the right side. And you notice if we wanted to, we could even pull our C out of here again because it's a linear constant velocity.